Alright, so we are going to do some questions related to using derivatives. So this is just going to involve the power rule. So the power rule that we discussed was d by dx of x to the power n is going to be nx to the power n minus 1. So this is the main formula that we're going to be using in this topic. This is, I think, the only formula we're going to be using in this topic. For question 1, we're going to solve the question by using the definition. So you can skip ahead because I don't think the definition is going to be tested. So you can start by looking at from question 2. I'll also do it directly at the end. All right. So the first part, I'm given y is equal to x to the power 4. And I need to find the gradient slope at the point 1, comma 1. All right. So using the definition of the limit, dy by dx, if I differentiate, has to be limit as h tends to 0, right? Then I have f of x plus h minus f of x divided by h. All right, so limit as h tends to 0, x plus h to the power 4 minus x to the power 4 divided by h. It's limit h tends to 0, and if you expand this using the binomial expansion, you get x to the power 4 plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the power 4 minus x to the power 4 divided by h. And these terms will cancel out. So eventually, you have limit as h tends to 0, 4x cubed. So if you divide by h, right, you get 4x cubed plus 6x squared h plus 4x h squared plus h to the power 3. And then if you consider h tending to 0, you will see that these three terms are going to be closer and closer to 0. So eventually, you just have 4x cubed. That is your derivative. Now, we need to evaluate this when x is equal to 1. Right? So when x is equal to 1, you just substitute 1 into this equation, and your gradient is 4. So that is your gradient at the point 1, comma 1 for the curve y is equal to x to the power 4. All right, so that is while using the definition, right? This is we use the definition to get 4. Now let's use the formula directly. So y is going to be x to the power 4. This is 4 is your n. Remember, n is your 4, right? d by dx of x to the power n is n x to the power n minus 1. So instead of n, we can substitute 4. 4 x to the power 4 minus 1. 4x cubed. So that is going to be your solution. And then you just substitute 1 here. X is equal to 1. So therefore, you get 4. So this, using the formula is much quicker, but this is how you get the answer by using the definition. And the formula actually comes from the definition. All right, so we're done with A. Let's do the same for B. We have f of x is equal to x squared minus 2x plus 3 at x is equal to 0, right? Whatever the output y value is, doesn't matter. We just want to find the derivative at a particular value of x. So if I use the formula, if I do d by dx of f of x, then I have to take the derivative of my right-hand side. And remember, previously we discussed that if it's separated by plus or minus, right? If it's separated by plus or minus, then I can take the derivative individually. So minus d by dx of 2x plus d by dx of 3. Right. So now let me give you another formula. That is d by dx of a constant, any constant k is going to be 0. Now let's think about it. What does d by dx give me? D by dx gives me the slope, right? A constant graph k looks something like this. So what is the slope of this graph? It's 0. There is no gradient, right? At any point, the gradient of this graph is 0. So that is why when you take the derivative of a constant curve, you're going to get 0. All right. So d by dx of x squared. So if you remember the formula, you bring n to the front, right? X to the power n is n, x to the power n minus 1. 2 minus 1 is 1. So I get 2x here. Minus, remember, you can take the constant out. We discussed this rule as well. And this derivative is 0 because 3 is a constant, right? So if you have a constant times your function, you can bring that constant out in front. So you have 2x minus the derivative of x. Remember, you can bring your power. X is the same as saying x to the power 1, right? You bring 1 to the front, x to the power 1 minus 1. X to the power 0, that is just 1. So you have 2x minus 2. So another useful thing to remember is this is going to give you 1. All right. So your solution is 2x minus 2, and then you substitute x is equal to 2, I believe. Sorry, x is equal to 0. And if you substitute x is equal to 0, you get minus 2. So that is your solution. Now let's use the definition to figure this out. All right, so let me erase everything, and we'll do this again by using the definition. So f of x, my bad, minus 2x plus 3 at the point 0, comma 3. All right. So now, f dash of x, which is the derivative function, is the limit as h tends to 0, f of x plus h minus f of x divided by h. It's the limit as h tends to 0. Now f of x plus h is basically going to be x plus h squared minus 2x plus h plus 3 minus x squared minus 2x plus 3 divided by h. If I expand the numerator out, I get x squared plus 2xh plus h squared minus 2x minus 2h plus 3 minus x squared minus 2x plus 3. All right, so we're going to have some cancellations. If you think about it, we have x squared and we have minus x squared. So these are going to cancel out. We have minus 2x. We have minus of minus. So we have minus 2x plus 2x. So these are going to cancel out. We have 3 minus plus 3 is going to cancel out. So we have limit as h tends to 0, 2xh plus h squared minus 2h divided by h. And this is limit as h tends to 0, 2x plus h minus 2. And if h is getting closer and closer to 0, this is getting closer and closer to 0. So we have finally 2x minus 2. And when you substitute x is equal to 0, you get negative 2. So using the definition, we get the same answer. All right. We have y is equal to 2 square root of x at 4, 4. All right. So dy by dx is just you differentiating the right-hand side. Now 2 is a constant times a function, so you can take 2 out and you have square root of x. Now remember, square root of x is just x to the power 1/2. So you can use the power rule. You bring the power to the front, you keep x, and then you subtract 1 from the power, right? N, x to the power n minus 1. So you get 2. So 2 times half. Actually, this is going to cancel out. So you get x to the power half minus 1, right? So that is x to the power minus half. And that gives you 1 over square root of x. Right? Because x to the power minus half is x to the power half in the denominator, and that is square root of x. Now, you have to evaluate this at x is equal to 4. That gives you 1/2. That gives you 1/2. Yeah. So one useful formula that you may want to remember is that this derivative of square root of x is 1 over 2 square root of x. So that is a useful formula that you may want to remember. All right. And another one is, d by dx of 1 over x is minus 1 over x squared. So that is another useful formula that you may want to remember. All right. So now let's use the definition to solve this. So the definition says f dash of x is the limit as h tends to 0, f of x plus h minus f of x divided by h. So you have limit as h tends to 0 to square root of x plus h minus square root of x minus 2 times square root of x divided by h. And 2, you can factor out the 2 from the numerator, and you can take it outside of the limit, actually. So that is one of the laws of the limit, but because we're not covering limit laws, so that's why I'm just using it directly. And this is not very important because the textbook only wants you to remember how to use a formula. So 2 limit as h tends to 0. Now what I will do here is that I will multiply by the conjugate. So the conjugate means I take the numerator, but I switch the sign. So it's not the conjugate, actually. It's like, I forgot the technical name for this. I'm so sorry. But like, you have whatever you have in the numerator, you're going to multiply by the same thing, but except the sign is going to switch. And the reason why we're doing it is because this is a minus b. We're multiplying by a plus b. And that is a squared minus b squared, right? So I can do square root of x plus h squared is just x plus h minus b squared is just x. Divided by, I have x plus h plus square root of x times h. Now x minus x is cancels out, and h divided by h, that is also going to cancel out. So you have 2 times limit h tends to 0, 1 over square root of x plus h plus square root of x. And if you bring values of h closer and closer to 0, you will see that it's just, you have square root of x plus square root of x. So you have 1 over 2 square root of x. And these cancels out. So you get 1 over square root of x, and you substitute x is equal to 4, you get 1 over 2. So this is using the definition. And finally, we have y is equal to 12 over x at x is equal to 2, 6. So x is 2. So dy by dx of 12 over x, we can factor the constant 12 out, 1 over x. Now remember the formula I gave you. It's going to be minus 1 over x squared. So minus 12 by x squared, and then you substitute x is equal to 2. So minus 12 by 4 is minus 3. That is your answer. So now, how do we get this formula? Remember, 1 over x is x to the power minus 1. So when you use the formula, you get minus 1, x to the power minus 1, minus 1. That is minus 2. So that is minus 1 over x squared. That is how we get the formula. So let's use the definition now. Using the definition, we know that f dash of x is limit h tends to 0, f of x plus h minus f of x divided by h. So is equal to limit as h tends to 0, 12 over x plus h minus 12 over x divided by h. Now I can factor out the 12 from the numerator. Alright. And now I can write this as x minus x plus h using the butterfly method, right? Multiply, and then I multiply together the denominator. I think I discussed this. And then I have h in the denominator as well. So when you simplify, you get this expression. You have 12 limit as h tends to 0, x minus x is 0, so you have minus h in the numerator. And you have h, so these h's are going to cancel out. And if you think about it, you have minus 1 x times x plus h left. And if h is getting closer and closer to 0, x plus h is getting closer and closer to just x, right? So if you just substitute h0 here, you see that this term is getting closer and closer to x, so you get 1 over x squared. And that is minus 12 over x squared. So that is how you get the same solution. And when you substitute x is equal to 2, you get minus 3. Alright, so we're done. with question 1. Now, for 2, I'm going to do things a little bit faster. So you differentiate, right? So the derivative, I'm going to represent it like this. You bring the power to the front, x power minus 1, 4. Same here, 9x to the power 8, right? 9 minus 1 is 8. Same here, minus 4, x to the power minus 5. Same here, this is x to the power minus 1, so the derivative is minus 1 x to the power minus 2 is minus 1 over x squared. This you can write it as minus 4 over x to the power 5, whichever you feel is easier. So I'm going to do things a bit quicker here. So we're done with the first 4 questions. All right. So the constant, right? Differentiation of a constant is 0. This is x to the power 2 over 3. Now use the rule. 2 over 3 x to the power minus 1 over 3, right? 2 over 3 minus 1 is going to give you minus 1 over 3. So that is going to be 2 over 3 times x to the power 1 over 3. That is going to be your solution for f. For g, remember, x to the power 3 times x to the power 2 is just x to the power 5. And if you differentiate x to the power 5, you get 5x to the power 4. And x5 divided by x2, that is just x to the power 5 minus 2, x cubed. And if you differentiate this, then you get 3x squared, right? You bring 3 to the front, x squared. All right, so we're done with 2. And remember, all we're using is this formula. Done with 1, we're done with 2. Now let's do 3. So now it says find f dash of x for each of the following, right? So now I'm going to do things very, very quickly, and I think you will see the pattern. You'll get used to it. So instead of taking 2 out and differentiating, you can just multiply this 4. When you bring 4 down, you can just directly multiply it. So when you differentiate x to the power 4, you're going to get 4 is going to come to the front, right? So your power in it is going to drop down. So 4 times 2 is 8. X, 4 minus 1 is 3. So directly, you know that it's 8x cubed. Same here. You bring 5 down. 5 times 3 is 15. X to the power 5 minus 1 is 4. All right. Here is the same, right? Your constant is half. So you bring 6 down. You multiply it by half, x to the power 5. So that is 3x to the power 5. Same here. Now this one, it's easier, I think, if you factor 3 out. And then if you differentiate 1 over x, you get minus 1 over x squared. So it's 3 over x squared here. All right. Here, so f is going to be 0, right? Because it's a constant. So for E, G, and H, so E, let me do it separately here. F of x is equal to 5 over 3 x squared. All right. So we can write this as 5 over 3 times 1 over x squared. And now, f dash of x is that you keep your constant and then you differentiate 1 over x squared, right? You differentiate the function, you keep the constant. And remember, 1 over x squared is just x to the power minus 2. So you bring minus 2 to the front, x to the power minus 3. So if you simplify, you get minus 10 divided by 3x cubed. So that is going to be your solution. All right. So this is multiplies, by the way. Dot, by writing dot, I'm just saying it's multiplication. We're done with E. For G, it's going to be f of x is equal to 4x over square root of x. Remember, this is x to the power 1. This is x to the power half. So you have 4. You can keep it as it is. X to the power 1 minus half is going to give you half, right? Using the simplifying your exponent gives you half. Now you can find f dash of x is equal to 4 times, remember, d by dx of square root of x. I gave you a formula for this. That is 1 over 2 square root of x. 4 divided by 2 is going to give you 2 divided by square root of x. So that is going to be your solution. And finally, we have h. So f of x is 2x square root of x divided by 3x cubed. So the numerator simplifies as 2x to the power 3 over 2, right? 1 plus half is 3 over 2, x to the power 3. So 3 is just 6 over 2. So you can keep 2 over 3, and then you can do 3 over 2 minus 6 over 2, right? So 2 over 3 times x to the power minus 3 over 2. And now you differentiate. It's the same as you keep 2 over 3 and you differentiate minus 3 over 2. And you get, you bring minus 3 over 2 to the front, x to the power minus, so you do minus 1 here. So minus 3 over 2 minus 2 over 2 is minus 5 over 2. If you subtract 1 from minus 3 over 2, this is what you're going to get. So 3 and 3, 2 and 2 cancel out. So you have minus 1 over x to the power 5 over 2. Or you can write it as minus 1 over square root of x to the power 5. That is what the textbook has given you. But that is how you do question 3. All right. Question 4 is the same as well. So 5a. I'm so sorry about that. F of x is 5x squared minus x plus 1. So if you differentiate, then you bring 2 to the front, right? You bring 2 here, you get 10, x2 minus 1 is 1, minus d by dx of x is going to be 1. So minus 1 plus 0. So you're going to get 10x minus 1. All right, so I'm doing things a bit quicker, but I encourage you to sort of pause and then try it on your own. But you're going to get 10x minus 1. For b, you have 2x cubed plus 8x minus 4. So if you take the derivative, right, f dash of x is going to be, bring 3 to the front. 3 2 is a 6x squared. 3 minus 1 is squared. Plus 8, factor out, d by dx of x is 1, minus 0. So 6x squared plus 8. That is going to be your answer. All right. C, you have 7 minus 3x plus 5x squared. dy by dx is going to be, differentiation of 7 is 0. You factor out minus 3, derivative of x is 1. So minus 3 times 1 is just minus 3. Plus, you bring 2 to the front. So 5 times 2 is 10. X to the power 2 minus 1. So that just gives me 1. So finally, you have 10x minus 3. All right. For D, we have x plus 5, x minus 4. We don't know how to, you could use the product rule, but that overtly, unnecessarily complicates things. So you just multiply things out. You have x squared minus 4x plus 5x minus 20, right? If you expand the brackets out, you multiply these two together, and then you multiply these two together. So you get x squared plus x minus 20, and then when you take the derivative, you get 2x plus 1. So 2 to the front, right? 2 times 1 is 2. So 2x and then 2 minus 1 is just 1. So 2x to the power 1 plus 1. Derivative of x is just 1. Derivative of constant is 0. So you get 2x plus 1. Now E. You have y is equal to 2x squared minus 3 squared. Now, this is something that is easier to solve using the chain rule, but since we haven't done the chain rule yet, we'll just expand it out. So if you complete this, that is going to be 2x squared squared minus 2 times a times b plus 3 squared is 9. All right, so that gives me 4x to the power 4 minus 4 3s are 12. X squared plus 9. And now if you take the derivative of this expression, you're going to get, if you bring 4 to the front, that is 16. 4 times 4 is 16. X cubed minus bring 2 to the front, that is 24. X to the power 2 minus 1 is 1. Plus 0 is just going to be 0. You have 16x cubed minus 24x. So that is going to be your solution. All right, so let me erase this. All right, so let me erase everything here. So F gives me 2x minus 5 over x squared. So that is going to be 2 over x minus 5 over x squared, right? If you simplify, if you write it as a simplified version, this is how it's going to look like. So it's going to be 2x over x squared, but then 1 over the x is going to cancel out. So if you differentiate this, then you're going to get 2 times derivative of 1 over x is minus 1 over x squared. Minus 5, you're differentiating x to the power minus 2. So minus 2 over x squared minus, if you bring minus 2 to the front, you have minus 10 x to the power minus 3. So you can write it like this actually. So finally, you get minus 2 over x squared plus 10 over x cubed. And that is going to be 10 minus 2x over x cubed if you simplify things out. But you could just leave it like this actually. This is also okay. So we're done with F. Alright. G is the same. You have f of x or y. Finding f dash of x and dy by dx is the same thing. So now let's write this. One easier way to do it is just to write it as like this. And now we can use the rule directly, right? So f dash of x is going to be 14x to the power 1. 2 comes to the front, 7 times 2 is 14x. 2 minus 1 is just 1 minus 3. Alright, so we have 14x to the power 1. And then for 3, you have minus 1 x to the power minus 2. Plus for 2, you have minus 2 x to the power minus 2 minus 1 is going to give you minus 3. So that is 14x plus 3 over x squared minus 4 over x cubed. So that is one way to solve this. And I think this might be easier if you're doing differentiation for the first time. Alright, so we're done with G. H is very, very similar. You can write y is equal to 3x plus 5 to the power x minus 1 minus half x to the power half, right? That is how you can write the third term. And now you can just differentiate term-wise. So dy by dx, y dash is the same. 3 minus plus 5 times minus 1, x to the power minus 1 is minus 2, minus half times minus half, x to the power minus 3 by 2. And that gives you 3 minus 5 over x squared plus 1 over 4x to the power 3 by 2, which is the square root of x cubed. So it's the same. Alright, so we're done. And finally, I, you have y is equal to 4x squared plus 3x minus 2 divided by square root of x. So if you divide each term by square root of x, you're going to get 4x to the power 3 over 2, right? This is to the power 0.5. 2 minus 0.5 is 1.5. 1.5 is 3 by 2. Plus 3 square root of x minus 2 over square root of x. And I can actually write this as 3 to the power 3 times x to the power half, 2x times to the power minus half. If you calculate everything out, you're gonna get this expression. And now we can differentiate this. dy by dx should be 3 times 2 x to the power 1 over 2 plus 3 times 1 over 2 x to the power minus 1 over 2 minus 2 times minus 1 over 2 x to the power minus 3 by 2. And if you simplify, you get 6 square root of x plus 3 over 2 square root of x. If you simplify everything, you're going to get this expression. So this is going to cancel out 1 over x cubed. So this is the expression that you're going to get. And I encourage you to sort of pause the video and think how I got to this point. Alright, so we're done with 4. Question 5. Again, it's the same question, you just want to find it out at a specific point. So dy by dx is going to be 2x plus 1, right? You bring 2 to the front. This is going to differentiate to 0. This differentiates to 1. The first term differentiates to 2x, 2 minus 1, which is just 2x plus 1. And then x is 1. So you're going to get 3. All right. It's the same here. So the first term differentiates to 0 minus... So the first term is going to differentiate to 0. And then we have minus 2 d by dx of 1 over x. And we know this, right? Or you can also think of it as 5 minus 2x to the power minus 1. This differentiates to 0. Minus 2 minus 1 comes to the front if you differentiate it. X to the power minus 2, right? I have differentiated this. So if 5 differentiates to 0, the second term differentiates to this. I have 2 over x squared. And now I can substitute x is equal to 2. I get 1 over 2. So that is B. And so because 2 squared is 4, and 2 over 4 is just 1 over 2. And for C is the same procedure. So y, I can write it as 3x over x squared minus 2 over x squared. So I can write this as 3 over x minus 2 over x squared, which is just 3x to the power minus 1 minus 2x to the power minus 2. And now dy by dx is going to be 3 minus 1 x to the power minus 2, right? If I differentiate the first term, minus 2 minus 2x to the power minus 3 if I differentiate the second term. So I get minus 3 over x squared if I simplify this, and I get plus 4 over x cubed. And I need to substitute x is equal to minus 2. And if I do so, I get minus 3 over 4 minus 4 over 8. Minus 3 over 4 minus 2 over 4. So that is minus 5 over 4 if you solve the expression. So we're done with 5. Alright, to find the gradient of the curve is the same thing, right? So I'm going to find the gradient of the curve at a particular point, and finding dy by dx of a curve at a particular point is the same thing. So y is going to be 2x squared plus 8x minus 5x minus 20. So 2x squared plus 3x minus 20. And dy by dx is going to be, if you differentiate this, 2 comes to the front. So 4x plus 3, if you differentiate the second term, minus 20 differentiates to 0. And then you need to substitute x is equal to 3. So you have 12 plus 3 is 15. That is the gradient at a point. And we have discussed this. The gradient at a point is just take the derivative at a particular value of x. Given that xy is equal to 12, find the value of dy by dx when x is equal to 2. So y is just 12 over x for x not equal to 0, right? And dy by dx is just going to be 12 d by dx of 1 over x. Or just differentiate 12x to the power minus 1. So 12 minus 1, x to the power minus 2. So minus 12 by x squared. And x is equal to 2. So when you substitute 2, you're going to get minus 3. And we're done with 7. So find the gradient of the curve where the curve crosses the y-axis. So the y-axis, if the curve is crossing the y-axis, then it must cross when x is equal to 0. So that's just what it's asking us, to find the gradient when x is equal to 0. Right? So dy by dx is going to be, bring 2 to the front, you get 10x minus 8 plus 0. So 10x minus 8. You substitute x is equal to 0, you get minus 8. So it's very easy. Find the coordinates of the points on the curve where the gradient is 9. All right. So you are given dy by dx is equal to 9. So you differentiate this, you get 3x squared minus 3 minus 0 is equal to 9. If you divide by 3 on both sides, you get x squared minus 1 is equal to 3. So I just divided by 3 on both sides. You get x squared minus 4 is equal to 0. And remember, 4 is just 2 squared. So you can write a squared minus b squared is a plus b, a minus b. So therefore, you can see that x is going to be plus or minus 2. Now it says find the coordinates. So we want to check the value, y values. So if x is 2, you put 2 here, you get 8 minus 6 is 2 minus 6 is just, minus 8 is minus 6. And then you substitute minus 2 here. You get minus 8 plus 6 is minus 2 minus 8 is minus 10. So these are going to be your 2 points. And we're done with 9. So let me just erase everything here. All right. Question 10. Find the gradient of the curve 5x minus 10 divided by x squared at the point where the curve crosses the x-axis. So basically, the y is going to be 0, right? Y is equal to 5x minus 10 over x squared, and we want to solve for y is equal to 0. If y is equal to 0, then it's going to cross the x-axis. So if I multiply by x squared on both sides, and assuming that x not equal to 0, then I get 5x minus 10 should be equal to 0, right? So x should be equal to 2. So we just want to find the gradient at x equal to 2. Now y, I can write it as 5 over x minus 10 over x squared. And I can write this as 5x to the power minus 1 minus 10x to the power minus 2. So dy by dx is just 5 minus 1 x to the power minus 2 minus 10 minus 2x to the power minus 3. Minus, you get this expression, right? Minus 5 over x squared plus 20 over x cubed. And now we need to substitute x is equal to 2. And when we do so, we get minus 5 over 4 plus 20 over 8. And 20 over 8 is just 10 over 4. So that is just positive 5 over 4. That is the gradient. If it says gradient, then we just want to find dy by dx at a particular point. All right. Question 11. This curve and this line meet at the points A and B. So find A and B. Okay. So we just want to equate the two curves, right? And if I bring all the terms to the right-hand side, I get minus x, I get this expression. And I can factorize this. Minus 3 plus 2. And if you check, when you expand this, you get this expression. Therefore, x is going to be 3, or x is equal to minus 2. And the reason why I'm doing the factorization very quickly is because we have covered this in chapter 2 or 3. So we have our two x points. But we also should be giving the y coordinate. So point A, let's say, is minus 2. X is minus 2. You substitute minus 2 here, you get 7. Point B is you substitute x is equal to 3. You get 1 minus 9 is minus 8. All right. Now it says find the gradient of the curve at each of the points A and B. All right. So what we want to do is we want to use this equation. F of x is equal to x squared minus x minus 6. Wait. Let me think about it. I think using either equation works, to be honest. So f of x is equal to x squared minus 4x minus 5. All right. So if I differentiate this, I get 2x minus 4. And then I need to substitute x is minus 2. If I substitute minus 2, I get 0. Sorry, no, I don't get my 0. So f dash of minus 2, I get minus 8. So that is the gradient here. And f dash of x is 3. I get 6 minus 4 is 2. So that is the gradient. All right, and I think if you actually differentiate this equation, it doesn't work. All right, okay, I misread the questions. It says find the gradient of the curve. So you want to use this equation. But only you're just given the points here. So these are going to be your answer. Minus 8 and 2. Minus 8 corresponding to the gradient of the curve at point A, and positive 2 corresponding to the gradient of the curve at 3. So it says find the gradient of the curve. If you gradient of the line is always a constant minus 3. Right? Mx plus b. Alright. So we're done with 11. Yeah, don't use this one. My bad. I misread the question. Okay. Alright, so let's finish off some of the final questions from this chapter, from this topic, and then we'll move on to the next topic. Alright, so question 12. The gradient of the curve at the point is 5, find the value of a and b. Alright. So first, we know that if x is equal to 3, y is equal to minus 3. So let's make an equation of that. X is 3 squared plus b times 3, right? And we can actually divide by 3 on both sides. And we will get a 3 plus b. So the first equation that we are going to get is 3a plus b is equal to minus 1. Or you can simplify it out, and if you divide by 3, you are going to get this equation. And it says that the gradient at this point is 5. So now let's find dy by dx. It's going to be 2a times x to the power 2 minus 1 is 1, plus b times derivative of x is just 1. Alright, and when x is equal to 3, this whole expression is equal to 5. Alright, so if I substitute 3 here, I get 6a plus b is equal to 5. And we know that 3a plus b is equal to minus 1. If I subtract these two equations, 6a minus 3a, that is just 3a. b minus b is 0. 5 minus 1 is 6. So a is equal to 2. And b, you will see that is equal to half, I think. No, sorry. So if you substitute a here, 6 times 2 plus b is going to be 5. So 12 plus b is going to be 5. And b is going to be minus 7. Alright. So that is a and b. So we're done with 12. Alright. So this is 13 is actually the same thing, right? So if I substitute 1, f of 1 is just 1 plus a plus b plus 7, which is equal to 5, right? If f of 1 is given to be 5. So a plus b plus 8 is equal to 5. A plus b is going to be minus 3. And then we know that f dash of x, if I find the expression, is going to be 3x squared plus 2ax, right? 3x squared from this, 2ax, 2 times a, and then 2 minus 1 is just 1, plus b. And so if I substitute 1 here at x is equal to 1, gives me 3 plus 2a plus b. And that is going to be minus 5. 2a plus b is going to be minus 8. And a plus b is going to be minus 3. So if I subtract these two equations, 2a minus a gives me a. B minus b, this cancels out, and we get minus 5 here. And if I substitute, I get minus 5 plus b is equal to minus 3. So b is positive 2. Alright, so we're done with 13 as well. 14. The curve f of x, ax plus b over x squared, has gradient 16 when x is equal to 1, and gradient minus 8 when x is equal to minus 1. Alright, so find f dash of x. So this is just ax plus bx to the power minus 2, right? So f dash of x is going to be a minus 2bx to the power minus 3, right? This gives me a, if you differentiate it, this gives me minus 2bx to the power minus 3. That is going to be a, this expression, right? Now I know that f dash of 1 is 16. So if I substitute the values here, a minus 2b, if I substitute 1 here, is 16. And f dash of minus 1 is minus 8. All right. So if I substitute minus 1 here, I'm going to get a plus 2b is minus 8. So a minus 2b, a plus 2b is minus 8. If I add these two equations up, I get 2a is equal to 8, a is equal to 4. And finally, if I substitute, I get this. If I substitute this here, I get this expression. Minus 2b is 12, b is equal to minus 6. All right. So that is 14. So 15, we are given this curve. And the gradient is 0 when x is equal to 1 and x is equal to 6. Okay, so f of x is equal to 3x squared plus, is x cubed plus ax squared plus bx plus 3. And f dash of x is equal to 3x squared plus 2ax plus b, right? If you differentiate this, you get this expression. So you bring 3 to the front, 3x, and then 3 minus 1 is 2. You bring 2 to the front, 2ax to the power 1, plus you bring 1 to the front. So b times x to the power 0 is just 1. So you get and then differentiation of 3 is just 0. So this is equal to 0 when x is equal to 1 and x is equal to 6. So we can form two equations. Substitute x is equal to 1 here. We get 3 plus 2a plus b is equal to 0. Substitute x is equal to 6 here, and we get, so 2a plus b is minus 3, by the way. That is equation 1. Substitute x is equal to 6. You get 3 times 36 plus 12a plus b is equal to 0. So 12a plus b from this is going to be 3 times 36 is minus 108 here, right? Now if I subtract these two equations, I get minus 10a is equal to 105, I think. So therefore, a is going to be minus 10.5, right? If I divide by negative 10 on both sides. And if I substitute 10 here, I get minus 11 plus b is equal to minus 3. b is, if I add 11 on both sides, I get 8. Sorry. Do I get 8? No, sorry. This is minus 22. Because 2 times a, 2 times this, is going to give me 21. It's going to give me 21. So if I substitute a into the first equation, I get minus 21 plus b is minus 3. So b is 21 minus 3 is going to be 18. All right. So we're done. Given that this is the expression, find the range of values for which. Okay. So find dy by dx first. dy by dx is going to be 3 times 2 is 6x squared minus 2 times 3 is 6x minus 36, right? And we want to see, we want this to be less than 0. If I divide by 6 everywhere, I get this expression. And I can complete the square here. I get this expression if I complete the square. So now remember solving quadratic inequalities. This is a quadratic inequality. So x positive 3, x minus 2, right? If I put something bigger than 3, this is positive, this is positive. So I'm going to get something positive here. If I put something less than 3 but bigger than negative 2, something like 0, then I get something negative. If I put something that is less than minus 2, like minus 3, so minus 3 gives me minus 6, minus 3 plus 2 gives me minus 1. So I'm going to get something positive again. So therefore, my x value has to be bigger than minus 2. It cannot be equal to minus 2. If it's minus 2, then I get 0. So I need to have an open interval here. So it has to be between minus 2 and 3. All right. And finally, we have question 17. We are given this equation. Show that the gradient of the curve is never negative. All right. dy by dx is 9x squared, right? If I bring 3 to the front. If I bring 2 to the front, it's 12x plus 4. All right. So now, let me factor out in 9 here. I get x squared plus 12 by 9 is 4 by 3, I believe. Yeah. plus 4 over 9. So now let me complete the square. Right? It's going to be x plus 2 over 3 squared. So I get x squared plus 4 over... Yeah, basically it's just this expression, right? So if you expand this, I think you will get this expression. X squared plus 4 over 3x plus 4 over 9. Yeah, pretty much. So now I have 9x plus 2 over 3 squared. So now if you think about this, this is a parabola. It is concave up, and its vertex is at x is equal to minus 2 over 3, something like this, right? So the gradient, or this is the curve for dy by dx, by the way. So dy by dx is always bigger than or equal to 0, right? If you look at this curve, then it's either always positive or it touches the x-axis. It's 0 at one point. It's never negative if you visualize the curve for this expression. So therefore, this implies that the gradient is never negative. And that is it. We're done with 17. And this is it for this topic.